Welcome to my channel. This is Study with me NCRT. So I would like everyone to take your NCRT or chemistry part 1 and take down the chapter for the page number 44 and let's start the class. I'll give you 3 seconds for that. Okay, I guess everyone took your NCRT notebooks, textbooks, so by this only you can study. So here, the speed of light depends upon the nature of the medium through which it passes. As a result, the beam of light is deviated or refracted from its original path as it passes from one medium to another medium. So when it passes from one medium to another medium, the light is deviated or refracted. This we already learned in the class 10. So it is observed that when a ray of white light is passed through a prism. So I'll show you. This is a prism and it's passed through it, and that it forms a light. So this is a prism. So this is a prism, and this is the white light. For example, this is a white light that goes, and here it get deviated. All the lights. All the color lights get deviated. This is what they're saying in this spectrum. The light of red color, which has the longest wavelength, is deviated the least. So red color is the longest deviated. Red color is longest deviated and the least. While the violet color, so let's see violet color. Yeah, like violet color. The violet color light, which is the shortest wavelength. So violet is short and red is long. Violet is short while the red is long. Violet is wrong. Violet light, which has a short wavelength, is deviated the most, and from the white spectrum that we can see that ranges from violet at. So what is the? Kindly note these. The violet range. The violet at the range of 7.50 into 10 power 14 hertz, that is hertz, and at a red to 4.4 into 10 power 14 hertz. So I guess you are opening your NCRT, so you can refer side by side. So this is 7.40 into 10 power minus 14 hertz, and this is 4.4 into 10 power 10 into 14 hertz. So there is no mile difference, so you should remember it. Repeat it me. 7.50 into 10 power 14 hertz, and the second one with red is 4 into 10 power 14 hertz. Such a spectrum is called as continuous spectrum. So now we are going to learn about continuous spectrum. Now we are going to learn about continuous spectrum. This is called continuous spectrum. A continuous spectrum is a spectrum which is violet at stand 15 into 10 power 14 and red 4.10, which is deviated the most and least deviated. So next let's see when electromagnetic. When here continue with because the violet emerges into blue into green, and that's why it's called as a continuous spectrum. So let's see why it's called continuous spectrum. Because the violet emerges into blue, and blue emerges into green, and green emerges into so on. A similar spectrum is produced, so it is the rainbow of the sky. So the match which I what's this called? Sorry, that's making it worse. This is called a spectrum. Remember that visible light is just a small proportion of the electromagnetic radiation. So visible light, we all know that visible light, and that visible light is just a very, very small portion of the light. radiation intersection with the absorbed radiation. So when electromagnetic radiations interact with the matter, atom and molecule may absorb energy and reach the higher energy. So this is important. When an electromagnetic radiation, you know what is electromagnetic radiation? It interacts with a matter, atom or a molecule. So when an atom or a molecule, this is atom, this is a molecule, or this is a matter, that time when it interact with electromagnetic, this is electromagnetic radiation. When the electromagnetic radiation interact with these three, it may absorb the energy, or such case it can also emit the energy and get into a higher state, so that it can get into a higher state. With higher energy, these are unstable. With the help of higher energy, these are unstable. These are not stable with a higher energy. For the returning to the normal energy state, the amount and molecule emit. For returning onto the normal stage, from the higher stage to the lower stage, they are emit radiations. They emit what? Emit radiations in various regions. Radiation in the various regions. Now, emission and absorption spectrum. So let's see what is emission versus absorption spectra. The spectrum of an radiation emitted by a substance that has absorbed energy is called emission spectrum. So what is an emission spectrum is? The spectrum radiation emitted by substance that absorb energy, is called as emission spectrum. Emission that's what it's called by, like emission spectrum. These emission spectrum atoms, molecules and ions that have absorbed energy radiation. So which have absorbed radiation? So the emission spectrum, absorbed radiation that are said to be at the excited state, state. So the emission spectrum radiation emitted by a substance that absorb energy. As I said, this is absorbed energy is called the emission spectrum. Absorbed radiation is said to be as it excited state. This emission spectrum is said to be on the excited state. That is very, very important point. To produce an emission spectrum, energy is supplied to a sample by beating it or irradiating it and the wavelength or frequency of the radiation. To produce an emission spectrum. To produce the emission spectrum, energy is supplied to a sample of heating or irradiating it and wavelength of the radiation spectrum. Energy is supplied to a sample key by heating it or irradiating it the wavelength or frequency of the radiation emitted spectrum as the sample gives or absorbed energy is recorded. So this is also already given in the ncert point of view. One second. That's this one. So you can read this once more time. So the spectrum of radiation emitted by a substance that has absorbed energy is called as emission spectrum, which absorb energy is called as emission spectrum. Atom, molecule, ion that has been absorbed energy are called as the excited. To produce an emission spectrum, energy is supplied to a sample of heating or irradiating it, and the wavelength or the frequency is emitted. A sample gives an absorbed energy is recorded. An absorption spectrum is like the photographic negative of an emission. So it is like photographic emission of the spectrum. So since we learned this much today, I'm gonna take you another lesson in another day. So kindly subscribe my channel and like and share. I think it's a good class. Kindly subscribe so that I can put more videos. I'm not motivated, guys, so kindly subscribe. Thank you.